So we're going to talk about the three possibilities first. So if you're picturing a line and a plane, what could happen? The line could be right on the plane, so that would look like that. In this case, our solution is a line. Now so there's infinite points, but it's a little bit different from when we were considering two lines or when we were considering two lines in two space or in three space, okay? Where we say there's an infinite solutions and it's just the same line kind of thing. But in this case, because there are parts of the plane that aren't the solution, we still will talk about a solution. So there's infinite solutions, infinite points in a way, that are the solution to this system between a line and a plane, but we will still state a solution. It'll be the equation of line. We'll see that down the road. What else could happen? What would that look like? Yeah, now it doesn't have to be a normal, so it could be any point where they cross. So there's one solution. The line passes through the plane or crosses through the plane. Whether it passes through at a right angle or not, I mean, that would be something you might talk about. You might talk about the angle between the line and the plane. But if we're looking for solving the system, we don't possibly care about what the angle, so whether it's at a right angle or not, maybe doesn't matter, right? We're just looking for the point where they cross. Okay, and what would be the third one? There's three. Yeah, so it would be like that. So there's no solution. The line is parallel to the plane. So in this case, the line is in the plane. In this case, the line is parallel to the plane. Now, as I said, it turns out this is actually a really simple process. You might think it would be harder working with a plane than working with two lines because planes are more complex. But it turns out there's a very easy way to solve. So we want the parametric form. We sub the parametric equations of the line into the plane and solve for t, assuming t was used for the parametric form. Does that make sense? Like, we don't have to use t in the parametric form. It's just the standard that we often use. So after we have established that that's our method, I want to go back to these three examples. And if the line is in the plane, you're going to get this, 0t equals 0. When you solve, after you've subbed in the parametric form, if the line passes through the plane and you have one solution, you're going to get t equals k, some constant. And if the line is parallel to the plane and there's no solution, you're going to get 0t equals k, where k is not equal to 0. So if you were solving a system of a line in a plane and you didn't have parametric form, you'd go get parametric form. That's what we want. Okay, there's not a different way of doing it. I mean, maybe there are different ways of doing it, but we don't want different ways of doing it. This way is super easy. We have to know the three interpretations, but they align with what we've seen in the past. Of course, if you're finding the point, after you've found the value of t, you don't have the point, so you'd have to go get the point, but otherwise you'd be done. Let's take a look at an example. This one's nice. It's already given to us in parametric form. Hopefully you don't mix up which one's the line and which one's the plane. And all we do is take the plane and 9x, but x is given over here. So 9 times 5 plus 2t plus 13y, but y is given over here. So negative 5 minus 5t minus 2z, z's over here, 2 plus 3t minus 29 equals 0. Solve for t. See what I mean? Pretty easy, right? So I've got my value of t. I'm going to interpret it. And then I'm going to go find those values. And of course, you could do this however you want, but using parametric form is probably a pretty easy way. We've already got parametric form, so why not? So this is 5 plus 2 times negative 1, which is 3. Whoops. Y equals negative 5 minus 5 times negative 1, so that's 0. And z is 2 plus 3 times negative 1, so that's negative 1. So L1 and pi1 intersect at 3, 0, negative 1. Any questions?